Okay, in this video we are going to talk about Overleaf. Well, as you already saw Overleaf environment in previous videos, uh, Overleaf is a cloud-based LaTeX environment, as I already mentioned. Unlike softwares like Microsoft Office, OpenOffice, LaTeX can be write with any preferred text editors. One of which is uh, Overleaf, which is a cloud-based environment, and you can always, no matter of which operating system you're using, you can simply access it through your browser. For example, only thing you have to do is go to overleaf.com. Simply you see the address here, and that's the website. It's pretty simple and straightforward. You can simply register here. You can register via your Google account, and I assume all of you can simply do this process and register in the Overleaf. Okay, I will go with my account, which is already loaded here. If you register in Overleaf in the beginning, you will see some environment like this. Maybe if you are watching this video in a time that Overleaf is changed, it might be a bit different, but now it looks like this. You have a sidebar at the left, which you can choose projects, and you will have the list of your project on the right side. You can access your account and projects and also help. So I want to show you the environment a bit. As you see here, you can simply create a new project, and this is all the projects you see here. Your projects, you might see why all the projects is different from your projects, because you can create projects and also share with others. So like video, if you are working in an article together with a friend or with a colleague, you can share with it. And archive project, trash project, and simply you can create your own preferred folder to categorize your files when they are like too many. So let's see, when we press new project here, blank project is simply, it creates a blank project for you. Example project is like the first example of some simple article for you. I will show it to you later. Upload a project. Obviously you can upload some LaTeX file inside the Overleaf. Import from GitHub. We are not going to talk about it now. And it also have some templates. As I already mentioned in previous video, one good thing about LaTeX is that you can use already predefined templates and just change it according to your need. For example, if you want to you want to submit an article, journal, book, formal letter, or whatsoever. Let's go and see all the templates you can find here. You see, you can see examples, template, and also search. Assume we are going to write an academic journal. You see here, there are many templates of academic journals. Like you will see many tags here, and as you see, there are, the list continues and so on. You can go and explore it yourself. For example, if I click on a template, it shows how it looks like, and I can even download it. I can view the source, and I can open as a template. Let's do it. It will load, and you see, you already saw in previous video how your input will be translated to an output here. Now as you see here, it might take a time because every time you put a code, it is being compiled with a LaTeX compiler. So let's give the time. As you see it's already like it's like a chapter of a book or article journal, and simply you can use this. You can explore the code and play with it a bit, and also you can change it. Just you see where we came from. I can simply, for example, change it to my first chapter start, and if I press recompile here, it takes time because sometimes since it's cloud-based might be a bit busy, but you will see here it changed according to my will, and you can change the text and whatsoever. So I just wanted to tell you, you can use many predefined templates, and also sometimes you go to an you want to submit a paper somewhere, and they give you these template actually, and you don't have to write it, like you don't have to put these every details. They give you the templates. You just copy and paste the template or load the template, let's say, inside your preferred LaTeX environment, which in this case is Overleaf, and then you just put your content, and then you download your file, and simply you can follow the instruction without any problem. Here you see, if you for example assume that your output is ready, you can download it as a PDF. So simply you will have your result, and so you can browse all the templates according to your will. And I want to show you this side. This side usually, or every time, let's say, the name of the extension of your LaTeX files are .tex. You see, so this is your main file. This is another file. This is another file. These are LaTeX file. This is bibliography file, but we are not going to talk about it. So here you can see the list of the files. You can upload a file here. Assume that you want, for example, you want to have an image here and you want to put it. You simply can upload your file and just drag your file here, and it will be uploaded here. But we will talk about it in our examples. I just wanted to show you the environment and to get familiar with it. So if you want to start a new project, usually for the purpose of this tutorial, I'm going to create a blank project, and when you press it, the window pops up, and you can just put a name. I put like simple tests, for example, and then I created it. It automatically loaded for me, and as you see here, Overleaf feels some, it's just like when you're creating a C# project, it feels namespace and feels like a main function for you, but it's simply the name here, which I put here, it's called a simple test. Also, this is my user, and this is the date for today, which it automatically generated, but you can simply delete it. As you see, now there is no code, and if I press like recompile, I'm getting an error. As you see, this is my main text file, but since it is empty now, compiler says there is no code actually to be field to be compiled. So we will start to create a document. So if I press the I already mentioned the keyword here is like backslash, and Overleaf helps us with many keywords. If you don't know, for example, sometimes you need autofill. For a start, I will write document because I want to document class. I want to define at first what kind of article, what kind of document I'm going to make. In this class, it is an article, so I put article and simply I press enter, and then I begin my document. As you see, you begin simply your document, and that's it. You see, Overleaf is filling it for you because your document should be started with begin document and end with end document. I will delete this part. So it should be some kind of this structure, and you fill this area according to your need. For example, I want to write hello class. Usually it's hello world, but let's go with hello class and recompile it. As you see here, you can see it. So it's like a simply making a first project, and Overleaf automatically save it for us. And if I want to download it, as I already mentioned, I can download it here, and here you can have access to your history. I already said your file is main.text. The name can be anything, but the extension should be tech. And if I go back, and you see I have my file here, and the owner is me, and I can relog in it here. So it's like a simple hello world thing, and we slowly talk about more and more. As you already saw, it's like a simple structure of a simple hello world document, as you can see here. We already mentioned that our special character here is like backslash. We have even different type of special characters, as you for example, as I already said, all the comments will start with backslash, but sometimes you might need to put a comment in your code. As you already know, comments is something that is in your code but wouldn't be appeared in the result, no matter if it's your C# program, or if it's HTML code, or even if it's like a text file like this. So in C#, for example, when you want to put a comment, you would put like /, and then you write like this is my comment, for example. But here it doesn't work like this. Here the special character for comment is this %sign. For example, I put it after my article here. A document can be can have different forms. I just can't like comment here. Here I chose article style. As you see, if I recompile it, so it's nothing will happen here. It means like your comment will be ignored by the compiler. It's actually just for yourself. Don't think it about now that your document is really simple. As imagine sometimes you're writing a book, sometimes you're writing a like difficult article with equations. Sometimes you know, and you are sharing it with a colleague, with a friend, or even for yourself to look at later. So sometimes you need to put comments, and as you already see, whenever you put %sign, you can write whatever you want, and your comment will be start with backslash. So that's the special characters, and we will follow with more now. So here you can see, based on our current code, we simply have a hello class sentence, okay? But in real world, when we are writing an article follows a standard structure. What do I mean by that? For example, when you are writing an article, let's shift it a little bit here. Article has a title, let's say, and article has a author, date, and whatsoever. Or even sometimes, now I'm talking about articles, but sometimes you are writing a book or chapter of the book, and it has a title, it has some kind of preamble. That this preamble, it's like a header for your documents. As I already mentioned, it's like a title of your book, it's title of your article, and whatsoever. So this called preamble in LaTeX. So we can now see how it's done here. So for this purpose, simply we already have a document, and we want to make a preamble. Preamble should be defined before your document is started, because it's a header. It's before the main document. You give some information to your document, you provide it, and then you ask LaTeX to put it in the right place based on the class of the document you already mentioned. So we have some simple keywords here. Usually an article has a title, right? So I put a title here, and I'd say let's work with LaTeX. Just simple. And then I will put something like, usually a document article has an author, and I say like my name, let's say, and a date. Simply the keys, and I will put like this year, let's say. Now I'm going to compile it, but it's not going to be to work, but I will explain later. As you see, nothing happened here. Why? Here we provide some information, but we haven't asked LaTeX to put this information simply inside our documents. I already say that everything which is going to be shown, it should be between begin and end of our document. So for this purpose, we already defined information. We ask LaTeX, so LaTeX puts the information I provided here at the beginning of my documents, and it's simply being done with make title command. So what does this make title do? It's use this information and put it in the header of your document. Let's recompile it. You see, you already see, for example, I haven't said that put it on the center, make the title bigger, then make my name just after it in the center, and put the year like that. It all automatically followed the structure of the article. So simply you might see here that in the beginning, yes, it might seem a bit difficult, but after a while, when you get used to it, you understand there are many things which are a routine, which are standards in official documents in academic style, that LaTeX will take care of all of them for you. We have other keywords, for example, in LaTeX. If I put /today, right, it automatically will get today's date and put it here. according to the time I'm compiling it, which in this case it's 28th of March 2002. So as you see, it's some kind of coding, and you cannot say it's a coding, but you are using a coding fashion to generate a document. So that was called preamble, and it's one of the key things we are working with, and one of the key things in LaTex. So here with this document, let's assume we're writing an article and we want to add an abstract in the beginning of our article. So as I already said, LaTeX is smart enough to understand the structure of an article, and things like abstract and some sections are already defined in LaTeX. So we have if we want to add an abstract, as I said, this is the whole body of our main document. We just simply I will put begin. Begin, and here I want to begin what? Abstract, right? It automatically fills and ends it for me. I leave it here, and here I'm writing something like this is an abstract for my documents. Let's say you can add for example this comment here, abstract parts, just for your own understanding. Here I have a tendency, I already said it in the course of the how to write a good code, that your code is better to be readable. For more readability, I usually use I indent my code, so when I can look at it, it's more obvious that this is just related to this part, and simply I can read it easier. So let's recompile it and see what's happening. As you see, the abstract is started at the beginning, and it automatically went, you see numbering, went to the next page and start the document in the next page, because it already understood that abstract should be in a page, and it's separated for us so we can see the actual document here. That's about the abstract. So here let's add something to our document. Let's talk about how to put items in our document. Well, for items, there is a keyword defined. It's called simply now. By now you must already slowly getting to know how the structure works. Like the main section for us always started begin and end, and each other section follows the same style depending on the what sections you want to add to the whole documents. For example, now I want to add let's say some items. I will add with a keyword begin again, and what do I want to begin? Itemize. It already has it, so it automatically put some item here for me, which I can just name. Let's say let's name some cities of Czech Republic. I put like Zlín, again item. Let's say Brno, or item, just whatsoever. Like let's say talk about not even Czech Republic, Berlin, for example. Okay, so that's a section that puts this item for us. So let's follow the same fashion, but now we can put another type of item here. Our items are not numbered when we are just using itemize. If you might say, okay, how should I make it numberized? I will explain it. We just simply put begin, and here we use enumerate. As you see here, again, same style. Let's talk about the shops in Zelin, for example. I would say like Kaufland and item penny. By now you already probably know them. Bila, oops, Bila, for example. Now I'm going to compile it. You see here the hello class is written above, and this Zelin Brno Berlin is in the style of this bullet style, and the name of the shops in Zelin, it can be whatever you want, are numbered here. And let's, as a reminder, let's put a comment here so we know this part. For example, this part is creating preamble, right? Let's recompile it. Nothing will happen. It's just for our own sake of understanding. So that's about items. So in this video, let's talk about how we can add images in our document. For the sake of more readability, I will delete these parts. I will even delete abstract. So we just have a simple document here, and as a reminder, this is a title, order, and this is the date. Let's put it like, let's add an image. Okay, then we have something like this. Okay, now we want to add an image. You know, I know when you're working with Microsoft Office, you simply drag a photo or simply insert a photo and you have it. But you already understood that in LaTex we define everything and we build everything from the scratch according to our need. So it means that if we want to add an image, we should at first save and put an image beside our file where our text file is located. In this case, which it's a cloud-based, this sidebar is showing is the place that our files are existing. Here it's only main.tech, which is this file. And if I want to add a photo, I should put my photo somewhere near this file, which, since this is a cloud-based, means I have to upload it. So simply it's a button here called upload. You can just press it and add the photo you want from your computer. Here simply you select it from computer, and I already just found a photo of the university and I downloaded it, and I drag it simply here and it's uploaded here. See, this is a photo of main building and this is the text file. So I want to now add this image which I uploaded here with this fashion to the image here. Okay, I will change it let's see a photo, and you know, I'm going to use a command, but it's not going to work at first. Then I will tell you why and how to fix it. So It's a command called include graphics, as you already see, and here we put the name of the photo. As you see, Overleaf is autocomplete the name of the file here. Here the name of the file is external content document. It can be a simple file .jpg. I just put it here, right? So now my photo should be shown, and but let's recompile it to see if it's work or not. You see here it cannot show my photo, but actually only show the name of the photo. Why? In previous videos and you see an error here, undefined control sequence. In previous videos I already mentioned that sometimes you need to load some functions, but here we are calling them macros, which already defined in LaTex, and those functions or those macros can handle stuff for you, in this case showing an image. So what do I mean by that? I mean, if you want to show an image and use this include graphics, you have to load a macro that makes you enable to show the image. What do I mean? It's simply like import in C# that you are working, let's say. For loading documents or for loading macros, there is a command called use package, as you see here. And here I want to show a photo. There are many predefined packages. For photos, I have to use a package called graphics with CX, as you see here. Now that it's loaded to my documents, LaTeX engine understand to use this macro so it can show a photo. Let's recompile it. You see, now it's a photo, but you see the size is not really nice and not readable. There's a let's, as you see here, it's already Overleaf already made a like warning that the image is big and it's not really visible in a good way. A comment in LaTeX has this style that you usually use this backslash, name of the comment, and curly bracket, like here or like here or like here, and then you put like some input here. But you can modify this comment in these brackets usually before the curly bracket. Here we want to adjust the weight of the image so it can be shown easier. Basically comments in LaTeX have some kind of standard fashion, which in this case, you see, for example, all the comments start with this backslash, and the input is usually inside the curly bracket, like here, which it says finishing of a document, starting of the document, other name is like this, and title is like this, and use package is like this whatsoever. But if you want to give the comment some options, some kind of modifier, usually we put it inside this kind of brackets before the curly bracket. Here, as you see, the image is too big. I want to make this image a bit smaller so it could be more scalable inside my document. Here there is a comment option you can use. You can put like width of the document, which means like it's obviously it's the width of your document, and I put it like I want it to be like let's say 60% of the weight of the document, which is going to be shown here. So I want it to get only 60%. So 60% of what? Here I would write of text width, right? So let's recompile it. As you see here, it's now located with this size located here. You can change the size or whatever, or you can even put centimeters and other SI scales, but here I put just simply 60% of text width is readable for me. And now, as you see, it's on the left side. Let's talk about one other comment. I want to put it in the center, right? There's a simple thing. I can just use you already know that I start all the sections with begin command. I would write begin, and I want something to be centered. So what to be? It already finished this center part for me. I want my document. Actually, everything between these would be centered, which in this case is my photo. So let's recompile it. You see, now my photo is in the center. Usually in articles you might want it in this style. So everything between these two would be in the center. So that's the way that you put photos in your text file. Since it's cloud based, we upload it first and then we add it using this command. For using this command, we need to load this package graphics, and that's it. So you see, sometimes our documents are getting larger and larger. Imagine you're talking about a book, an article, chapter, and they are sometimes quite huge, and you have to divide them to some sections. So in LaTex there are some keywords for defining sections, and it's simply the keyword name is section. So let's see how to make a section and also some subsection of the section. So here, as you see, if I put section, I can put a name for my section, and let's say my first section, that's the title, and then I'm going to label it. Why do I mean by labeling it? It means it has a tag or it has a label that later I can refer to this section. We will see it as we go down. So I would say label. This is the key for defining label, and then I put a name for it, like my first sec. Let's say that's a label of my section. Then I want to put some subsection. Usually I already talk about it in my how to write a good code, which even applies here to indent the subsection of a section, no matter if it's a loop in programming or if it's an if section or it's just some part of a LaTeX. So just for the sake of more readability, I put a subsection with the subsection keyword, and I said my subsection, and I will write like this is a problem I am going to solve, and put another subsection, my other subsection. No matter what you're writing, it's just for the sake of example. And then this is just a simple solution, let's say. Then I'm going to make another section, and section my second section, right? And I'm going to label it with label key, and I put it like second sec. Okay, here I put another subsection. So you just following the instruction, like how it's going to make how it is like to make a LaTeX document. You just define the parts, define the objects, and go through it. So in this subsection, I put a title for it: the other type of part of documents. Okay, that's it. And now this is the part I'm going to talk about. You see, in this subsection I want to refer to this section. It happens a lot in scientific articles that you had a section and you want to refer it simply, and you say like in this part, or in the part number 1 or number 2 we were talking about this, and now we see the result or whatsoever. So we simply want to refer here. So here there is a keyword, and for example I want to say in, and use this sign, and then use ref keyword. Okay, so you already see the places which I labeled like this or this are shown by Overleaf here. So as I said, in this example I want to refer to my first section, so I choose my first section. We had a problem, right? So, and I want to compile it, and you will see what will happen. Okay, you already see here, it already create for us that we have a section, my first section, which is here, and it is numbered for us. Also it has 2 subsections, like 1.1, 1.2, and for each of us we wrote something just as a sample. And we have the second section here, and it is already numbered for us as well. So here, as you see, we are referring here to the first part. So it automatically it says in 1, but this is the number of the section we are. So I put just in the section, I put the section here in the section, and then recompile it. So here it's written in the section 1, for example, we saw let me make it more clear with space. So you see in the section 1 how it's understood that it's section 1, because I referred here and it automatically put the number of this section for me and the rest of the sentence that we are seeing a problem or whatsoever. So now the difference between LaTeX and something like Microsoft Word is being more clear. In Microsoft Word, you simply, like, the software has no idea, no understanding of meaning of each part. Okay, but somewhere like LaTeX, you define each places, and then you ask LaTeX engine to connect these parts together, and the output would be something structural for you. And just imagine now I want to refer somewhere else, and instead of deleting the whole documents and refer and write it again, I just change my reference here. Instead of my first section, for example, I will refer to my second section, or assume that one of your sections is going to be changed. So you change you only change the reference and all of your sentence, and recompile your document, and all of your document will follow to will change according to the reference you are giving to them. So it's basically it's some kind of structure you are giving to your document that
later if you want to do some change, it really makes your life way easier. So that's about the sections, which we already understood how to create them. Okay, now let's talk about bibliography in LaTeX. In scientific documents, or generally every formal documents, you have to refer to your sources. Assume that, for example, we have a book and I want to write like this, like here you can find a good book about LaTeX, right? And I want to here I wanted to cite a book. So how to do this in LaTeX? Well, let's go and talk about this left bar, which we already talked. Here you can see the list of your files here. In LaTeX, you have to make a separate file for your references and then put the references in a special format and then call them inside your text. What do I mean by that? Well, simply let's start and do it here. Here you can create a file, plain file, and I will put it, and it has to have a specific extension. For example, let's say I will call it bibl, and the format should be ended like this, like .bib. So you choose a name, whatever you want, and then you put extension as bib, and let's create it. Now you see here I have list of my files, and this is the file I just created, but here it's empty now. And my file here, my citation, should refer to this file as a database for my citations. Okay, in LaTeX the citation has a special kind of format, but we don't want to read it to write it manually. We will use a simpler technique. In what way? So you probably heard of Google Scholar. I will open it and then I will talk about it. So Google Scholar. So this is Google Scholar. In your browser it might be white, but here it's just black. It's not a matter of importance now. It is some kind of search service for from Google that you can find, and you can search through scientific and academic sources like famous journals, books, libraries. So rather than searching in general like normal way you're using Google, if you use scholar.google, you only search through the scientific materials. For example, if I want to show you a good book about LaTeX, this is one, and it will search and finds you material about the keywords you put here. You see here it's written like Springer, it's name of a famous journal, or this one, or this is like about International Conference of Computer. So books.google, you see there is the places that Google Scholar search is scientific and formal academic databases, and here at the bottom of each row you see, for example, related articles. As you see, related articles cited by 82 here. It means like this book is cited in other 82 scientific journals that Google could find. And this small sign here, that's what we are going to use. I don't want to go about on Google Scholar. I just wanted to, for some of you who don't know Google Scholar, I just wanted to show you. And Google Scholar has this small button, and it helps you a lot for citing your resources. Like that. If I press it, it shows me the citation and in different style. These are different style of citation. We don't want to talk about this now, but here, list of the software and a list of the materials that you can use for citation. For example, EndNote is usually its extension on Microsoft Office, but now we want to use this style, BibTeX. Simply I press it, and it gives me the structure that I can put in my LaTeX database. I just copy it, and I will show how I will use it. I already told you that I should put my references in different file, which is like here, and I should write it in different format. But I used Google Scholar to find the format, so I don't have to write it, I don't have to put a comma, maybe you might forget it or you might make a mistake, so I simply put it here. That's all I want. So this is one data. Assume, for example, if you have more books, you do the same process and you put your other reference, then your other, so on. So I go back to my main file. So if I want to, in LaTeX, if you want to refer to a file, you simply put this sign and then the always keyword like this, and use the keyword cite. It's similar to refer, which we did in the section part. So I put cite, and here it automatically will go and find the key in my bibliography. But for the sake of this tutorial, I don't want to use autocomplete. If I put it here, that's all. But I don't. I will go to my bibliography, and I just want to show you this is the key. The first thing after @sign book you see here, like after it could be sometimes it's not only book, but this after curly bracket, the first thing you need is your key. So this is your key, always the first item, and you go to back to your main file and just paste the key here. As you already see, you can do it with autocomplete, but I just wanted to show you. Let's make it a bit bigger. So here we are. But to finish our progress, our process, you have to use two other keywords. First of all is you should use bibliography keyword, bibliography, and then put the file name that your database is in, because it might happen that you should tell the engine that which file you are actually using. Sometimes now it's because it's just here. I just put the names. If you are using a local software for LaTeX, you have to put a path here. Okay, then in this case my database name is bibl.bib. That's it. And other key is my bibliography style. So bibliography style, and let's just put it plain. So that's all. Just remember that. Once again, you put your data in bibliography file. How do you find it? You will use, for example, some tool like Google Scholar, and if you find your book or whatever you want, you use this button. and then you go for bibliotext. So that's it, you copy it and you put it here. Then you go to your main file and use this style of keyword and find the key of your reference. Then you tell LaTeX which file is your source, which in this case is this, and your bibliography style, you put it plain when you just copy paste it like that. So let's recompile it. As you see here, now I have the style of my output. Here you can see, here you find a good book about LaTeX. As you see, I didn't mention it's first, or I didn't put any brackets here. It automatically made it for me. Even if you see, it's a bit like bold, and it automatically generate these references and numbered here, and you see, like made it italic and put everything like special format. So if you use this, you might not, you can be like sure that you're following the style of references correctly, because for example, assume that you are using this, you want to do the references in Microsoft Windows, and if you are not using external extension like EndNote, and if you want to put reference your document, you will find it difficult, especially if your document is getting longer and longer, and then you change one citation or add or remove, and then you have to go to references and correct all of them. So in softwares like Office packages, you usually need an external extension to do this for you, but here we use it in bibliographic graphic style. So that was one of the key points in each article. One thing about this tutorial is I just want to show the structure of the LaTeX to make you get more familiar with it, to make you see the structure and how is the logic behind it, and then you can dive into the details and find more details about it. So we cannot cover everything about LaTeX, since understanding LaTeX it's a course itself. It takes like many weeks. So but I try to talk about the most general thing that you might face, and then you can even open and see many type of sources and analyze them and see other resources and so on, which are not for you. So one of the other most important thing in LaTeX, which is the favorite document generator, especially between the mathematicians and computer scientists, since in the concepts of LaTeX, I said it's really useful when you want to use formulas and things like that. So there are various ways to enter a mathematical equation in LaTeX. One of which is using inline method, which I'm going to talk about. Assume I want to just put a, let's say, simple mathematic equation which we all know. I will delete this one to just make it easier and cleaner. So that's what we have here. So I will write, for example, the formula is let's say I want to talk about, it's like the formula of this. At first, let me tell you that there is a special character that it tells to LaTeX compiler that a formula is going to be started. So from this part to the finishing part, which I show you, make it like a mathematical formula. And what is this special character? the one which I prefer is backslash and open the parenthesis. So that's it. It means from here to the place which I close it. Let's close it here. Again slash, but this time close the parenthesis. So you put backslash and opened it, and then you again put a backslash and then closed it. Between these two, everything will be like a mathematical formula. So let me expand it a bit like this. Now I will write my formula. For example, I will like a plus b by the power of 2. You show it like this, the power, and is equal to, you all know this formula, a power of 2 and b power of 2 plus 2ab, right? So if I let me make it a bit nicer. So the formula is like this. So let me compile it. So you see here the formula, it's automatically made it a bit italic, as you see it in the equations, and also put these powers above. You already probably have the experience. If you want to make it in Microsoft Office, it's really time consuming, and sometimes it's messy, sometimes you shift it a bit and everything will be like reshifted, everything will be rearranged. But in this in LaTeX, you can, after you get used to it, you will find it way more easier, especially when you are using with when you have too many equations to put. There are many different ways, but this is the preferred one, because as I said, like later when you look at it, you can simply find it, like where did you put a equation, because here with these special characters it's more readable. There is another way you can put it. You can say, like, if I put this dollar, you see Overleaf automatically put another dollar for me as well. So, and between these two, whatever I put, it would be like that again. For example, x2 equal to x, right? So let's recompile it. You see, x2 is equal to x and x. So this is another way, but this one is the preferred one. And there are many various ways, and there are many sources about how to put formulas in LaTeX if you just Google it. And but since we are just covering the basics, I just want to show you this that LaTeX has such ability that you can use and simply put your equations here. So that was called inline mathematics, which I already showed you. You put a formula inline within a text, but sometimes, especially in more mathematical articles, you want your formula have their own space. They are bigger and they are more complicated, which you should put a space, especially inside your article for them. This is called displayed mathematics, and we will show some examples of that as well. Let me delete it and recompile it. So just okay. Here, for example, if I want to put an integral, let's say, and as you already know, integral or such things are really difficult to make in something like Microsoft Office. So here we have equation and integral, let's say integral. So you know, I already talked about inline, which you started with backslash and open the parentheses. The difference between inline mathematics and displayed mathematics is, instead of this parenthesis, you put a bracket like this. So I put it here and I will close it. I recommend you can close it after you finish your equations, but I usually like to do this style even in programming, to open something and close it and fill the between according to my need. I put a tab here. You don't have to put a tab, but we already know this makes our code more readable for later if we want to refer to it. So I was talking about the integral. LaTex have keywords for different and many mathematical equations as mathematical signs. For example, integral. And as you already know, everything starts with backslash. It's called int. So this means like we are going to put an integral, and you know integral has a starts from a point and finish in a point. So let's put it like, let's say 1 to 10, for example. Just something. And so it is the sign of integral. You already know it's something like long s, and then it's like x in power of 2 dx. So let's recompile it, and you see here we are having our integral here, and you can do it in another way as well. As you already remember, probably I told you in inline, if you put a dollar sign, everything in between would be inline equation, inline mathematical expression for you. But in the same way, we can have it here, but for the displayed mathematics, instead of $1 sign, it's better for you to you should have $2 sign here. So you can see it here, and in between whatever I put, it's just similar like this. But we usually prefer this style. Why? Because it's more readable, because something is opened and something is closed, and when you see this, for example, you can understand it was finishing. It's a finish of some equations and some mathematical expression. But here, since the start and finish is just like each other, you might have sometimes you might get confused that where it started or where it finished. But we will, for the sake of tutorial, we will go in this style as well. Again, I put a tab to move my sentence a bit. It's for just readability. If I put it here, it's no difference. So everything, as I already said, starts with backslash. For let's put a summation here, and before that, let me write it like here we have a summation. So that's it, and the keyword here would be sum, and followed by a square underscore. So you know what I'm talking about, these sigma signs that usually starts from one number and finishes in a number, and then equation can be followed. You will see it easier when I compile it. So it starts from, I will put it start from I is equal to 0, and up until let's say n, and it's equal to let's go with fraction. Fraction starts with a frac keyword, and as you all know, fraction is something divided by something. That's why it has two curly brackets. The above part you put here, and this is something down to the fraction. So I will put, for example, here n plus 1. So, and you don't have to put a space here. I just put it for more readability. And let's say 10. So let's now recompile it. So you see here, You see here this sigma sign for summation. It starts from 0 to n, and this is a fraction. This part is the first part which we are which we wrote here, and this is this part. So as you saw, you can have different type of style for putting mathematical equations. This is called displayed mathematics. It's for equations that gets their own space. As you see, it has its own space, unlike inline style, which is inside, for example, a sentence or something. But when you want to have an equation and you have this equation to have its own space, you use this style. As you see, the difference here is only instead of parentheses, you use brackets, or you can use double dollar. But I personally prefer this style because it's more readable. So that's it with displayed mathematical equations. So just like sections that we can refer to, you can basically refer to everything. But it might happen a lot in your paper that you might want to refer to equations you wrote, and we simply can make it in LaTeX as well. So for this, we can use another style of writing equations, which it's creating an environment. We use backslash and begin, and here you put equations. Let's help with autocomplete, and you see it finished it for us. This is a starting point and this is finishing. Everything in between will look like a equation when we compile it. But why I use that? Because when I use this, I can refer it easy and label it, and everything that you can label you can refer later. So just like the sections, I put the backslash and put label and just put a name here. Let's say, for example, first EQ, let's say, like equations. And here I write equations like E is equal to MC by the power of 2, which you all of you know it, or at least saw it somewhere. And here I want to refer, if I compile it, it will be shown as just like equations, but here I want to talk about these equations. So in my paper, and I see like here in, let's open parentheses, and I refer to what I want with backslash reference, as you see, and Overleaf automatically detects my labels and says, do you mean that? And I say yes, and I close the parenthesis. We see a very well-known equation. Okay, so let me compile it. You see here, it's written in here in 1. Let me make it a bit bigger. Yeah, now you can see. Here in 1, we see you see it automatically turns like equations, like you see this style power, and it's labeled it. It is the first equation, and then I referred it here. How? With the reference keyword. So whenever you label something, basically you can refer to it later. I told you how to write equations with using special characters, but this is another way that you create an environment and you label it and then you refer to it. So that's it with referring to equations. So we already talked about how to put equations inside our document and text, like inline format, but sometimes you want to put the text inside equations, for example, or inside mathematical expression. You want to write like here x power of 2 is equal to 1 shows that x is this or that. So for this reason we have to use a package which gives us some more abilities to do with mathematical expressions. The package is named called ASMath. So I'm importing it, and this gives me some ability to use for my purpose. So as we all know by now how to start our equations, I put it, and then let's close it. So I already says everything in between now counts as equations by the LaTeX compiler. But let's go over it. So I will put like x by the power of 2 is equal to 1, and now I want to write shows that, or implies, let's say. For that there is a keyword, that this keyword is inside this package, and the keyword is text. Open and close it. So I will write implies x plus minus 1. I will talk about it. So let's compile it. You see here x equal to x by the power of 2 is plus equal to 1 implies x plus minus 1. This is the plus minus keyword in LaTeX. If you put it, it will be shown like this sign, plus minus. So for many special characters, LaTeX has its own keyword, and you can use them. So you can see, if I use only implies, it was counted as part of equations. But when I use the text, which is in this package, LaTeX compiler knows it's a text which I want to put in between my mathematical expression. So that's with it, which sometimes you can use in your LaTeX documents. So by now I think you should get the core and the basic and the idea behind the LaTeX. I don't expect you to know everything about the LaTeX, because this course or this week's aim is not to cover LaTeX, since it's a course for itself. Like, it can take weeks just to cover LaTeX. I just wanted to show you what is LaTeX and what is the logic behind it, and by now you must understand it at least a bit, to what is the standards, how to work with LaTeX, what is the keywords and how to put equations and so on. LaTeX is not only limited to the papers and books, you can even make presentation inside LaTeX, and there are various ways and various packages for different needs you can import, you can use, and you can even make like a full book in LaTeX. By now you can see, I understand that at the beginning it might look a bit different or even difficult when you compare it with Microsoft Word, that you directly put what you want, but after a while, when you get to know it, it's some kind of things in life that at the beginning you might find it difficult, but when you get to know it, you can't leave it, you know, especially when you want to work and use with academic papers and academic style of documentations and so on. So I don't expect you to know all the keywords, which I always say there are thousands of them, or at least hundreds of them, and but it's enough for you to understand. You can load templates in something like Overleaf, and then modify the template according to your need. At least now you can understand what is the keyword, what is the sections, so you can modify it. And even there are many other keywords you haven't faced by now, but at least you know the logic behind, and you can, if you face it or if you need it, you can simply Google it or search it or see the many various references. Sometimes when you go to for example, conference website, you see they already prepared the documents template for you. You just copy paste the document in your preferred LaTeX editor, in this case Overleaf or your desktop version, and then you modify it by your own need and by your own will. It's enough for you to understand what is what in that template, which by now you should know it. And then for the things that you are not faced now, you can simply, there are various templates in the internet. Just if you Google LaTeX template, for example, for academic writing, LaTeX template for presentation, or LaTeX template or whatsoever. Even some people make their resume with LaTeX, and even Overleaf provides you some templates for. I already showed it in the beginning of the Overleaf, that it gives you some academic templates, resume templates, and whatsoever. So that's for now, that you know the core and logic of the Overleaf, and I hope it was useful for you and you enjoyed it. So that's for now, and goodbye.